After learning the basic identities in trigonometry, so let us use these identities in the real problem and let us see how to solve the trigonometric problem by using what? Yes, trigonometric identity. Okay, so I have written one question here. So if you see this question, 1 upon 10a plus cot a, which will be equal to cos a into sine a, right? So I will take left hand side, should I? So let me take left hand side. So in the left hand side is written that 1 upon a plus cot, right? So now look here, can I write 1? Answer is yes. So if I tell you, can you tell me how I can expand 10? Yes? Wow, great. So sine a of cos a, right? Similarly for cot a, what I can write? Cos a upon sine a. Wow, great. So next what I can write? So what I can write, can I write 1 upon? So if I want to add these two, I have to take the LCM. So if I take LCM for the denominator, so the LCM will be what? Let me make some little bigger. Cos a into sine a. Are you with me? Okay, cos a into sine a. So when it is divided, you know that, then it will be sine square, again cos square, can I write here? Sine square a plus cos square. Now we can find out. Okay, so can I write in the next step here? Is it visible? So I will write the same thing here. 1 upon instead of sine square a plus cos square a, what I can write? Sine square a plus cos square a, yeah, it's always equal to 1. So sine square a plus cos square is always equal to 1. So I am writing 1 and divided by what? Cos a into sine a. Is it visible? Answer is yes. Now you see, this is what? Denominator. If I want its reciprocal, the reciprocal I can write here. So finally I can, if I want its reciprocal, I can write in this form. So which is equal to cos a into sine a. So finally we reached the right hand side. So therefore this is our right hand side. Now we started from left hand side and we reached at the right hand side. So this is how, this is the basic trigonometric identity we are using in some problems and we are getting the solution. Any question? No question? Now let us go to one more question, right? So this is the question on the screen. So for this question, we have to use some algebraic identities. Okay, there are some problems which will be, we have to use some algebraic identities. Okay, so if you see here, you can see 1 minus 10a whole square plus 1 plus 10a whole square, right? So if you remember what we learned in algebra, can you tell me what is a plus b whole square? Answer is a square plus b square plus 2ab. Yeah. Similarly, if I write a minus b whole square, so then how can I write? A square plus b square minus 2ab. Can I write? So if I want to add these two, can I write here? A plus b whole square plus a minus b whole square. So similarly, if I add these two, can I add these two? You can see here minus 2ab plus 2ab cancel. So a square plus a square, 2a square. Do you know this addition style? Similarly, b square plus b square to 2b square. So therefore, I can write 2 into a square plus b square. Any question? No question. So instead of a plus b whole square plus a minus b whole square, I can write 2 times of a square plus b square. Are you with me? So the same thing I want to write here. Okay, let me take left hand side first. So if I write left hand side, so in the left hand side it's written that 1 minus 10a whole square plus 1 plus 10a whole square, right? Okay, by seeing these algebraic identities, you can tell me 1 minus 10a whole square plus 1 plus 10a whole square, what it will be? A plus b whole square plus a minus b whole square, which is equal to a square plus b square. So I have to write here 2. Instead of a square, what I can write? 1 square, great. Instead of b square, what I can write? Wow, right. So now if you remember, I told you one identity. What is that? C square a minus 10 square A, which is equal to 1. This is also one identity, trigonometric identity we learned in the last class, right? Say square A minus 10 square A equal to 1. So if I want only say square A, can I write 1 plus 10 square A? Are you with me? Any question? No question? Now similarly, if I write 2 here, 1 square is 1 plus 10 square A. In the next step, what I can write? Can I write 2? Answer is yes. And 1 plus 10 square A. 1 plus 10 square A. Yes. So it is what? Say square A. So therefore we took left hand side and we reached at right hand side. It is very easy. Did you understand any question for you? Which is equal to your right hand side. Now one more question is on the screen. So this question also we have to, for this question also we have to use some trigonometric identity, right? If you remember, I taught you while I was teaching algebra. So I told you that a square minus b square, which is equal to a plus b into a minus b. Is it visible? I will change the ink, of course, right? Similarly, if I want a fourth minus b fourth, right? So in the place of a fourth, can I write a square up? Similarly, in the case of b, can I write b square and its whole square? Right? So in the next step, you can see this is a and this is b. Consider for a moment, if it is a and it is b, can I write in this style? How can I write? A plus b into a square minus b square. Yes, great. So in the next step, what I can write, I will write the same thing here, a square plus b square, but in the next step I want to open this one. How can I open? Great, a plus b and a minus b. Okay, so exactly same thing I will be using here in trigonometry. Many times we will be using this trigonometric identity with algebraic identities. If I take left hand side, in the left hand side I can write sine a fourth minus cos a fourth. In the next step, what I can write? Can I write directly in this style? So this is the final thing I want to write. Okay, so I can write sine. Can you tell me in this form? Sine square a plus cos square a. So here what I want to do, I will write this form, sine square a minus cos square a, right? Okay, so is it correct? A fourth minus b fourth, again is okay, correct. Now this is correct. So now you can remember sine square a plus cos square a is what? 1 into, look here, we want in the right hand side we want sine square. So then it is not necessary. We'll change cos square into sine square. So if you remember, I told you sine square a plus cos square a equal to 1. If you want cos square, if you want to change cos square in the form of sine square, so then in place of cos square a, what we can write? 1 minus sine square a, because in place of cos square you write sine square. So similarly, this is 1, okay, I can write. So I can write sine square a minus, in place of cos square, look, so you have to be very careful while you are dealing with negative sign. So you will be writing 1 minus sine square a. Are you with me? Now, in the next step, 1 I am not writing. If anything is multiplied with 1, it will be same. So now I am writing sine square a. So this is minus plus minus 1, again minus minus plus sine square a. Finally, sine square a plus sine square a. How many sine squares? 2 sine square. So 2 sine square a, again minus 1. Finally, we reached at what? Right hand side. Are you with me? So this is your right hand side. Okay. Now one more question. Okay, so one more question is on the screen. So if I take left hand side,
is it necessary to take left hand side always?
No, it is not necessary. We can take right hand side and we can get left hand side also. Okay, if you want, I can take right hand side, no problem. Okay, so if I take right hand side, so in the right hand side we have what? COS is a plus cot a whole square. So let me see if I am taking right hand side whether we are reaching at left hand side or not, right? So can you tell me in place of cos a, can I write 1 by sine? Answer is yes. Similarly, in place of cot, can I write cos a upon sine a? Any question? No. So this is whole square, right? Now, if I take, what I can take? LCM. So what I will get? LCM is what? Sine a right? So then next one is 1 plus cos A. Yeah, because sine A is the same, LCM is same, then we can write it in the form, and outside is what, whole square. Now this square is for numerator and this square is also for denominator. So can I write what? Yes, 1 plus cos A whole square and divided by sine square A. Are you with me? Now if you remember, sine square A plus cos square A equal to 1. Okay, so in place of sine square, can I write 1 minus cos square A, right? Now the same thing I'm going to do here. So I am writing 1 plus cos A whole square divided by, in place of sine square I'm writing 1 minus cos square A. Okay, if you see, can I make 1 or can I write 1 square, because both have same meaning. Now you can see A square minus B square. So can I write 1 plus cos A into 1 minus cos A? Any question? Because you can see 1 in the sense we can write 1 square. So if it is A square minus B square, which is equal to A plus B into or times A minus B. The same thing I am going to write here. So this one you can see it is whole square. Can I write twice? Answer is yes. So can I write 1 plus cos A into 1 plus cos A? Since it is whole square, I can write twice multiplication. And now as the denominator, A square minus B square, can write 1 plus cos A into 1 minus cos A. Are you with me? Now if you see here 1 plus cos A and here 1 plus cos A, both cancel. Then finally what we are getting? 1 plus what? Cos A. So cos A upon 1 minus cos A, which is your what? Right hand side? Oh, left hand side. Okay, left hand side. So we started from right hand side and we restart left hand side. Any question? No question. Okay. So if any equation is there, so if the equation is correct, so right hand side is always equal to left hand side and the left hand side will be always equal to right hand side. No matter what you can take left hand and prove right. Okay. So the more questions I will be sharing to you in the form of PDF and you can solve. So the more detail we'll discuss in the next class. Okay. Bye. See you.